Okay, so let's talk about the history of I. Since the 1500s, that's a long time ago, the square root of a negative number has been called an imaginary number. In the late 1700s, the Swiss mathematician Leonard Euler first introduced the symbol I to represent the square root of -1. So he's the guy you can blame for this. It is evident that we cannot rank the square root of a negative number amongst possible numbers, and we must therefore say it is an impossible quantity. But notwithstanding this, these numbers present themselves to the mind. They exist in our imagination, and while we still have a sufficient idea of them, since we know that by the square root of -4 is meant a number which, multiplied by itself, produces -4, for this reason also, nothing prevents us from making use of these imaginary numbers and employing them in calculation. And so, this is no longer part of his quote, defining imaginary numbers made it possible to solve previously unsolvable problems. So, it actually did, by having this I concept, it allowed them to fix some proofs that weren't working, and they were able to solve some things they couldn't solve before. So anyway, this math that you're learning, it's just kind of, to me, it's kind of cool that this guy figured this out in the middle of the 1700s, and I'm still talking about it today. Isn't that kind of cool? Not many like smart things that people thought about back then are still talked about now. That's one of them. All right, a function. A function versus a relation. All right, this is what you're learning for today. So if you're taking notes, today is the 15th, and it's functions versus relations. A relation is any combinations of two numbers. Like, for instance, if I have like 2 goes with 3, and 3 goes with 5, and 5 goes with 7, that is a relation. It's got two numbers that go together. But to be a function, you got to test and make sure that it doesn't break the rules for functions. Functions have one main rule, that any input must have only, now if I take the time to write something out in handwriting, it's probably worth at least abbreviating it and putting it in your notes. Any input must have only one output. And just so you know, these are the inputs, and these are the outputs. So any input must have only one output. Going back to the old function box, like if it's just a imaginary box that we're putting numbers in, if I put in a 2 and a 7 comes out, and then I put in 2 again, and this time an 8 comes out, doesn't that seem kind of messed up to you? That's what messes up a function, is if you ever have an input that you put into your function and it gives you two different things, then that's messed up. So on a graph, so if this is, let's say, 3, these are the inputs down here, just like they were the x's on our little points. The inputs are here and the outputs are the y. If I have a 3 put in and I see that on my function it comes out here, then it better not give me a different thing for my y. And like if I put in a 3 again and I get an answer up there, it'll be breaking the rules for functions. And we have a test on a graph called the vertical, what? The vertical line test. And if it ever touches the equation, touches the graph twice, then it wasn't really a function. So in this picture, my little sketch would pass the vertical line test, because if I move this line along, it only touches once at any one time. But if I ever made it like double back on itself, then it's not a function anymore, because at that input of 2, I'd have 2 outputs, there and there, and that's not good. Okay? So that same concept here can be written in just points. Is this set of points a function? You don't even have to know what the function rule is. Like in this case, it looks like I add 2, and then I add 2, but this one I only added 1. You don't have to figure that part out. That doesn't matter. All that matters is that any one input never had 2 different outputs. Now, what could I add to my list that would make it not a function anymore? Give me any example. Yes? Yep. If I throw that in the mix, now it's not a function anymore because one of my inputs had 2 different outputs. Okay? So there's the rules on functions. The vertical line test is whether or not something is a function. You can tell by its picture. So just real quick, function or not a function? Not a function. How about function or not a function? Function. All right. What if I told you that this part was actually straight up and down? Not a function. If this is truly straight up and down, then will it pass the vertical line test? Over here it does, over here it does. All it has to do is fail at once. Bang, right there, it touches it more than one spot. Okay, so if it's truly straight up and down there, then it would not be a function. All right, good enough. Function notation is just a fancy way of writing y. This is a little, I don't know, pre-done thing that somebody made. And it's true. Instead of y equals f of x, you just write f of x equals x plus 5. Instead of like y equals x plus 5, you can just write that. In other words, y is the same as f of x. All right? So if I was graphing, normally you go x and y, right? When you're doing functions, what do you replace with what? Replace the y with f of x. So then your graphs look like this. Okay? So don't let that bother you, this whole f of x. It's just the y. That's all it is. It's just like y. All right. So moving on. This function is not it's not nice and clean. We copied it and made it bigger, and it kind of like got a little sketchy there. But if I want to figure out f of 8, that basically is telling me a number. It's telling me an 8 that is the x. They're trying to tell me to put an 8 in wherever I see an x. So really, f of 8 is just 2, and I'm going to leave an empty spot for the x. See how I just rewrote it with an empty spot for the x? That's a smart way to think of an x, as an empty spot. An empty parentheses, to be exact. So when I drop in a number, if it's got a negative, drop it inside the parentheses. All right, back to this. I'm putting in an 8. So I'm going to put an 8 here, put an 8 here, and then I'll get the answer. 2 times 8 is 16, plus 5 is 21. Over 8 minus 3 is 5, 21 fifths. Do I have to make that into like 4 and 1 fifth? No, I do not. It's fine to leave it as 21 fifths. All right. I'd like you to figure out that one for me, please. On your paper. And do it the way I suggested. Leave an empty spot for x. I know these are pretty easy ones, but when they get intense, that's a really good method. So where you have an x, put an empty spot, then drop in the number that you want in there. I'm sticking in -7. You get -14 plus 5, which would be -9 over -10. And the 2 negatives cancel, and what do I get? 9/10. Yep. Raise your hand if you had that. Good. Okay, that's evaluating a function. See, evaluate. You just stick a number in. It's easy. Okay, here's another one. F of x equals 4x plus 9. Find x when f of x is 21. Wait a minute. Last time they were telling me a number to stick in for x. Do you see how this is different? They're not telling me a number to stick in for x. They're telling me f of x. Now remember, what's f of x the same as? What? So basically they told me y is 21. They didn't tell me x, they told me y. You see how if you tell me x, I can stick it into the x. If you tell me y, I can stick it in for the y. So this is 21. Do you see an f of x up here? So you replace the f of x with 21. So you just put a 21, not where the x is. You put a 21 here. 21 equals 4x plus 9. And then you just subtract 9 from both sides and divide by 4. Get the idea there? All right, so either they can tell you x or they can tell you y. In this case, y is f of x. All right, so here's another one. This gets more complicated. Just a second. I want us to keep it simple for now. If I had f of x equals 2x squared plus 1, and I wanted to figure out f of 3, did I tell you x or did I tell you y? I told you x. I told you x is 3. So you stick it in just in your head. Do that quick. Raise your hand when you got it. Come on, it's not that hard. Yes? It is 19. All right. How about f of x is equal to, let me try, 2, 3. Did I tell you x or did I tell you y? I told you y. So don't stick it in here. Stick it over here. 3 equals 2x squared plus 1. And then you'd subtract 1 from both sides. And then you'd divide by 2. And this one's got a twist at the end. Would you solve this one, please? And see if you get the right answer. I know you think it's super easy, but it's got a twist. Don't say it. You figured it out, didn't you? Good. Hold on. So 2 equals 2x squared. That's easy. And I guess divide by 2. So divide by 2, divide by 2. And 1 equals x squared. So x has to equal 1. What's so twisty about that? 1 squared is 1, isn't it? There is a twist. Yes? You're right. I'm going to do the square root. So why is the answer that I've given you, it's not really wrong, but it's incomplete? Come on. Yes. Yes, it should be. That's all it takes to get the problem wrong. Why? Because 1 squared is 1. It isn't negative 1 squared, also 1. There's 2 answers. Watch out. Whenever you're taking a square root of a variable, the answer to it is 2 things. Okay, so this is actually the absolute value of x is 1, which is why x is plus and minus 1. They'll both work. Think about it. 1 squared or negative 1 squared gives you the same thing. All right. So now, if I said f of x is 2x squared minus 7, and this time I say f of x is equal to negative 7, where should you put that negative 7? Where the f of x is, or where the y is, yes. And then, go ahead, solve it, please. Got the answer already? Cool. Just tell me what to do then. Don't give me the answer, but tell me what to do. 7 equals 2x squared minus 7, and then add 7 to both sides, and I get 0 equals 2x squared. Now what? Divide by 2 on both sides. I'm just going to do it one step at a time, and you get 0 equals x squared. So what's the only thing you can put in there for x? 0? How about negative 0? Is there such a thing as negative 0? All right. I mean, if I say negative 0 and put it in my calculator, it'll actually take it, but it doesn't mean anything. So, yeah, the answer is 0. Did I just tell you there's always 2 answers? Well, it's the absolute value of x is equal to 0 is what you really get. And what works in there? Only one thing in this case. If you had put plus or minus 0, you should just sort of like slap the back of your hand and don't do that again. 0 is better. Okay. So either they're going to tell you x or they're going to tell you f of x, and you evaluate it. Those are about half the assignment, and it's pretty easy, but one little twist. If they give you f of 3, stick a 3 in for x. If they give you f of x equals 3, then you stick a 3 right here. But what the heck do you do if they say f of q? Stick a q in for x, exactly. They told you that x, this is the x spot. I told you that the x that you're supposed to stick in is q. So you stick a q in. F of q is 2q squared minus 7. Well, what do you do then? You leave it because you don't know what q is, so you just leave it that way. And your answer would be 2q squared minus 7. They're just telling you to stick this q in for x. Even if you don't know what it is, you can leave that in your answer. All right. And I think we're ready for this one. This is called a compositional function, f of g of x. Now, on a hard problem, where do you start? In the middle. And you work your way out. What's g of 2? That's easy, isn't it? Just stick the 2 into the g function. G of 2, I put a 2 here and a 2 here, and I would have g of 2 is what? 4 plus 5 is 9. So g of 2 is 9. So then, g of 2 gets replaced with 9. So now it's really f of 9. Isn't that pretty easy to do? Yeah. F of 9, I just stick a 9 here and a 9 here. I got 9 times 4 is 36 plus 9 is 46 minus 1, 45. We're going to do another one like that. If f of x is equal to 2x minus 4, write this down. And g of x is equal to x cubed. What's f of g of, let's keep the number fairly simple, 2. F of g of 2. How do you start the problem? By figuring out what? Don't tell me the whole answer, but how do you start? You figure out g of 2. You got to know this. So start figuring out g of 2. Once you got g of 2, you figure out that that's like 75 or whatever, and you put it in there. Then you figure out f of that. So it's substitution. It's one little thing at a time. If you haven't already done anything else, figure out g of 2, please. G of 2 is 2 cubed. G of 2 is 8. So I replace g of 2 with an 8. And now I'm really figuring out f of 8. F of 8, I stick in the 8 right here. F of 8 will give me 2 times 8 is 16 minus 4. 16 minus 4 is 12. Raise your hand if you had 12. All right, good. And you're on the right track. All right. Let's use the same f of x and g of x. And this time, I'd want you to figure out, this is trickier, f of g of p. You're in an accelerated class. Earn it. For those that are stuck, how do I start? Just tell me how to start. Yeah, figure out that. And I take the p and I stick it in there. And when I stick it in there, I stick it in there. And so what is g of p equal to? P cubed. So wherever I have a g of p, I can put a p cubed. I have a g of p right here. And so I can put what? P cubed. And then f of p cubed means I put the p cubed into the f function, which is right here. So I put a p cubed in right there, and I have 2 times p cubed minus 4. And can I do anything more? No, I can't. So there is my answer. Raise your hand if you had that right. All right, good job. Okay. G of 1. All right. Let me think. Did they tell me X or did they tell me Y? They told me x. They told me x is 1. On a graph, where is x 1? Well, x is 1 right here, but there's like nothing there. Maybe I should like extend it out, and then do you think that point might be important? Yep, that's the 1. So if they told me x, what do they want? They want y. And so what's the y? Or in this case, in this graph, it's not f of x, it's g of x. G of x is like my y. 3. The answer's 3. You get that? Let's try the next one. G of negative 2. So what did they tell me? Did they tell me x or did they tell me y? They told me x. They told me x is negative 2. Find a spot where x is negative 2. And at that moment, what they don't want is x. They already told me that. They want the y. At that spot, what is it? 0. Good. Because at x is negative 2, that's right here. That's this line right here where x is negative 2. That's the important spot. And the x is negative 2. The y is 0. All right. On this one, what did they tell me? Did they tell me x or did they tell me y? They told me y. They told me y is 2. And this one's got a twist. Y is 2. Y is 2 is right there, so that must be it. But there's something more to it. Yes. There's y is 2 all along here, isn't it? So isn't there 2 spots that are important? That spot's important, but so is that spot right there. It touches twice. Now, didn't we say it can't do that? No, that's a different kind of line. This is a horizontal line. If it had touched twice with this kind of a line, then we would have had a problem. But it's not a vertical line, it's a horizontal line. So it's okay if it touches twice. So it's okay if there's 2 answers. What am I trying to find? Am I trying to find x in this problem? No. Now, wait, yes I am. They told me y in this problem, right? So I'm trying to find x. X is what? Well, there was actually 2 things. X is one thing and x is another thing. What are the 2 different answers? At that one, what's the x? 0. At that one, what's the x? 2. There's 2 answers. All right. That's some iPad kind of stuff. All right. If we had to do this, g of 1, it'd be very simple. I just stick in a 1 for x. They told me x. If x is 1, do it in your head. Did you get a small negative number? Good. You stick in a 1 here, and you just get 1 minus 4 is negative 3, but then the absolute value of that is positive 3. But then you make it negative again, so it's negative 3 plus 2, which makes negative 1. So the answer is negative 1. On this one, did they tell me x or did they tell me y? Tell me y is 2. So I'm going to go put g of x is 2. I don't put the 2 in for the x. I put the 2 in for the g of x. So that's a 2. All right. I don't know if you've solved equations like this in a while, but you subtract 2 from both sides, and I get 0 equals negative x minus 4. There's actually 2 things that could make it 0. No, actually, in this case, is there only 1? Well, tell me one thing that would work for sure. If x was 4. Yeah, I was thinking of something else. Yeah, this is just, there's only one answer that would work. So x must be 4. So that's it. All right. Next one, they tell me g of 6. That means they told me x is 6. That's the main thing I need you to pound into your head is when are they telling you x and when are they telling you y? In this case, they didn't tell me x. They told me y. All right. Good enough. And to be or not to be a function. You remember that part about at the beginning about passing the vertical line test? And the other thing about one input should have only one output. If one of the inputs has 2 different outputs, it's a problem. So this is easy. Vertical line test. Is it a function or not? Yep. How about this one? Nope. How about this one? Yes. It passes the vertical line test. How about this guy? Notice how it's pointing to two different things. No. How about that one? Yes. Even though it's weird, it's not like they put in two different time and got two different answers. They only got one answer for one, they got one answer for two, one answer for three, one answer for four, and that's okay. It's when one thing points to two different things. Like if I had, on this next one, if I had it pointing to two different things, then one gives me one and one gives me three, that would have been bad. All right? But as it stands, yes, this is a function. And how about this guy? Yes. All right. I can't remember if there's, yeah, I remember what that's about. The next part is independent and dependent. And my father-in-law's property, he lives on a small lake, and the lake got overrun with carp. And carp are really tough on a lake, and unless it's a really big lake like Lake Minnetonka and can handle it, if it's a small lake, if you have a bunch of carp in there, just them swimming around all the time kind of causes a lot of silt on the bottom of the lake, and the eggs from the other fish, they basically eat them, or they get so that they can't attach to anything because there's so much motion on the bottom of the water because all of these carp. And anyway, once carp get in the lake really bad, sometimes you have to just get them out of there, get all the carp out of there. And the only thing you can do is poison them. So if you poison the carp, though, the same thing that kills carp kills the kind of fish that you want. It'd be great if you just catch all the carp, but you can't because you're going to leave enough in there that they'll keep breeding and stuff. So you just can't get rid of them. So the DNR, the Department of Natural Resources, decided to poison the lake. It killed every fish in the lake. Okay, it doesn't kill them instantly, but as it gets more and more and more poison in the lake, eventually the fish can't handle it anymore and they die. So if I was talking about graphing it, independent versus dependent, which one depends on the other? The number of fish in the lake and the amount of poison. Which one's dependent? Yes? Kind of, because how much poison they put in will depend on how many fish are in the lake. But answer this question for me. Does the amount of fish care about how much poison is in the lake? Does how many fish you have depend on how much poison is in the lake? How about if I say it that way? Yes, because if I have lots of poison, it will kill all the fish. Okay, so the amount of fish depends on the amount of poison. So the fish is dependent on the poison. Does the amount of poison in the lake care how many fish are in the lake? Poison doesn't care about the fish, so the poison is independent. Okay, so some of these are trickier to figure out than others. Independent versus dependent. What's the one thing I said was always independent? Doesn't care about anything. It always doesn't care. Yes, time doesn't stop for anything. Time stops for no man is a quote from some English. Really? What was it? Because of science. Because science is messed up. I would love to know more about that in a minute, but we're just pretty much done here. And I've got to stop recording soon. All right. That's actually not the homework. The homework is a worksheet, which I'm about to hand out. So here we go. Okay.